Good morning. I didn't plan on streaming today, but now I had an hour for myself. I thought that, yeah, let's do it. Let's do it. Yesterday we made a jump from the language reference guide into the in-depth overview, which is kind of a weird way over in-depth but overview. So let's go to where we stopped. Let's take a look at the code and see where we ended up. Yeah, that's right, the repeater thing. I'm not sure where I would use it. And I don't know, I don't think you can do it with a variable, right? So you couldn't just say, oh, how do you, that's how you make a for loop. Does it know this notation? Apparently it doesn't, because it could be fun to try to add stuff to it in a loop and see, because I think it's only compile time because it's a const, but you made it into a variable. But that might be only for the variables inside the content, not the array itself. Yeah, sorry about the cat in the background if you can hear it. It's been annoying since 3 o'clock in the middle of the night, and he keeps meowing because he wants to get outside, and he can't just run around outside. He's an indoor cat, but he has seen some birds apparently, and he wants to chase those. And I get that, but not right now. Let's see. Oh, maybe because it's the same name, we just use I. That's a usize variable's value. Unused, haha, yeah. That's what you think. But what I want to do is this. I want to remove this one. And then in here, values, add something like this. Or should we just do this? Remove that one. Then what does it say? It's never mutated. Ah, come on. It really is. I'm actually adding stuff to it right here. So I would consider that. But maybe it's because the content isn't being mutated, but it wasn't before, so that doesn't make sense. But this can be the compiler editor intelligence that says this is not the compiler. The intelligence that says I don't see this. So let's try. I think I'll just get an error because I don't think that you can change this because it has to be known by compile time. It's never mutated. That's kind of funny. It wants to say it's the same error, because we are actually mutating it right here, right? We are adding an integer to it. Again, I have no clue. And that's okay. It's okay not to know. I've been programming for, well, since I was, what, 12, 13 years old? So, and yeah, I'm getting really old. So, started on the Commodore 64 in BASIC, punching in games from different magazines, having it not work, having to figure out where the typo was, and then moved on to the demo scene in assembler, and moved to Amiga, also assembler. Had a lot of fun with that one. This 68,000 processor. I think it wasn't it 68,000? I don't remember. It was really amazing. You could add and subtract addresses and offsets in one go, and you could just make some weird effects easily for demos. And it was kind of, if I remember, it was the other way around, so it was data equals address or something. It was from left to right instead of from right to left or something. But yeah, I remember loving that one, and how fast it was, and the different processors. But yeah, those were the days where you could actually hold the entire memory in memory, not as today where we have 32 gigabytes of memory and you have no clue what's going on where, because it's controlled by the operating system. Back then you had that memory and you had access to it all. So, but okay, you had also only one program running at a time. So, but okay, it says it's not being mutated, so it's not that it's not being used. So this won't help, because that's just making a use of it. But that it doesn't see this as being mutated. Because if we make it into a const, as what it's actually asking for, I don't think that this will. But again, this should fail. And of course that doesn't fail. Huh. That is kind of funny. Okay, let's try with 10. And let's see where it fails. It will fail here. But we can write out something. Debug console. Why didn't it output anything? At least it should have output the... It outputs hello world. What's going on? Oh, I'm just being away from the program one day, and it's just, oh, what did I do and when and why? I'm running the program, I'm not running the test. So of course I should be running the test. Yeah. High compile time, false use size, ignored value. Yeah. All non-void values must be used. To discard the value, assign it to unsigned values. But I'm giving it a value, right? I'm adding this to this. But maybe I should cast it, because it needs to know, because it can't just from the value here. No, that I can't do. Or maybe it's because I haven't given it any parameters yet. Yeah, let's try again. No. Type unit is not supported. Array initialization syntax. Okay. And I can't just use this as is, as this usize. That's not possible. That was what I was talking about in one of the previous streams, that this usize used for for loops, as soon as I wanted to use it for something, I needed to cast it, because no other structure is actually using this usize. So we are back to that annoyance. But maybe it's because I don't know how to use it. Type U32 does not support array initialization. But let's, okay. Still, I don't think this will be possible. I know I'm kind of fighting a brick wall right here, because I think this is compile time. It needs to know how big it is, because this is an allocation on the, I guess, the stack, because it's just in this scope. So it's going to be allocated on the stack. But if you want to expand it, I think we need to do a new allocation, right? Because you're not sure that there's room after this one. That's why it wants to know it at compile time. And with this, I don't think it will know the size of the values. The values. I don't remember what we called this. Was it a tuple? Yeah, I think so. It's just a struct. Const. Yeah, you see, this already knows how big the structure is. So as soon as we try to add something to it, it will fail. But let's make a Google search or DuckDuckGo search how to create a struct with an array type. Boom, boom, boom. Do we have good idea? Yeah, no. Compile error. I expect compile error. Unclear compile message. It's GitHub. Maybe I should add that this is for SIG. It's called a slice. That's right, not a tool. This is a slice. But this is for C#. That's not SIG. But yeah, it marks it as C#, but I think it's for SIG. Const array of this and this. No. You know what? Instead of finding this, just accept that that's not how to use this. But right now I want to check how to use for loops. I guess there must be some of the simple things that I use every day. Sorry, just give me a second here. Yeah. Let's see, a for loop. Luckily we have this, which does some of the boilerplate for us. So this is what's gonna be looped over. This is what's gonna be repeated, and this is the values. But how can we? What values can we use? Or syntax can we use for the for loops? Or we can loop over an array. Of course, makes sense. An inline for on a struct of fields. That's some reflection. And again, a buffer. And again, the same. Struct of fields. And okay, I think that maybe the language reference is better here. test over message. Message again, an array. Now we have the address or content. Sorry, pointers points to addresses. Ampersands points to the content of that address, right? Oh, you can loop over multiple? What is this magic? Give me a second. This is weird. I like that. Let's just try this one. Oh, screenshot. Okay. Fumbling fingers. Let's just do this. Haven't. What? At times, this is really annoying. Let's see. We have some integers in array. 100 that is undefined. Can we access these undefineds and just read that part of memory? Or do we need to initialize it before we ever touch it? This is a really weird way of writing stuff because it says from 0 to something, but that's just adding an index, I guess. So we are still iterating over this array, but we want to have another value that goes from 0 to whatever it needs to go to encompass all of these. And then we point to that address. Oh my god, I'm not good at this. That's some of the things that's just not thought about in C# and Java, because you don't work with pointers and addresses directly. So maybe it would be a good idea to output. Sorry, as always, when I start the stream, the throat needs to be cleared. So we had a good output here, right? Yeah, this one. Or maybe debug. This one, yeah. So if we're just gonna take some integers, this one, and say we want to see what this actually is and how do we make a pointer to it? It's in there, because we can't really do that. Or maybe we can. That depends on what print functions are available. It actually is able to take a const of U8s, but these are usize. So again, I don't know if that would work. No. Invalid format, D for type. Yeah, it sees this pointer to an array. Is it this one? So that is seen as a pointer to an array of the size of 100 with integers of size 32. Then let's go back to the reference, because I think that we had this in the beginning of this document, right? Yeah, where we had all these outputs that, yeah, this one. No, we can't just give it an array of ints. We need to tell it exactly what's in there. Yeah. Dagnammit. But let's take this one. That should work. Click to run test. Yes. It's still having issues. Why? And I can't just do this. Have it figure it out itself. This is the hard part of learning something new. In the beginning, you have no clue what you're doing, what works, what doesn't work, and you feel like you're not moving anywhere, and you are not moving anywhere or getting anywhere. But then as soon as you start, I always see it like a concrete slab in front of you, and you are pounding at it and nothing happens, and then a small grain of sand falls off and you start peeling at that point, and then suddenly you have chunks falling off, and then at some point you can actually see through the wall and start doing something with this new language or whatever problem you're facing, and then you just expand on that hole until the concrete slab is gone. So this frustrating starting week is always the most annoying part, and exposing myself to the internet doing this is weird, but I hope it shows to people that you can't do everything from day one. It takes time to learn. But I'm not sure that this is the best way of learning. I feel like I'm missing a more structured learning experience with this, because from the beginning here we just have hello world. That I do understand, but already there it uses this. What is that? That was called, just had it down here, slices. And you then have pointers and different kinds of type annotations, and it's too unstructured. And I think you can feel that in the streams, because we're not really getting anywhere because of this. So maybe we should go for a good learning page instead. But again, learn, there's a guide, build systems, but I don't want build system. In-depth overview, that was too much. Why Zig when there's already, yeah, I don't need that. Code examples, always good. But again, if you don't have the foundation to build on, that's not gonna help you. A tool, tools, useful tools can help you write Zig code. Yeah, getting started. If you're all ready to start a program, getting started. Already been there. Yeah. Online learning resources. Okay. A project-based book, the Zig guide. Ziglings. I like the word ziglings. But let's open all of these and see what looks like a good place to start. Oh, that's a book, a free book. Installation, hello world, language, assignments. See, that's more what I was looking for. So yeah. So let's not, when was this? The last year, but it's being updated. Might be a good resource. I don't know about the book. This is an open source technical introduction book for the Zig programming language, which is a new general purpose and low-level language for building optimal and robust software. Yeah, sorry, I have a hair just tickling the edge of my nose. The syntax of the language, where it compares to C and C++ and Rust. Again, I haven't touched C for the past, what, 25 years? 25 years. So I have nothing to compare it to. So maybe this is more like if you come from C, C++, or Rust, then this will be good. So far, this is winning. Exercises. Again, I don't want to do exercises before I know what to do. But okay, this what's covered. Assignment, arrays, strings, ifs, whiles, for loops. Yeah. Okay. No. Oh, yeah. I did do some stuff on this exercism, but I found it not really helpful in a learning capacity. It was more like a test for yourself and your programming skills. And apparently I'm not used to doing this kind of tasks. I think it's that it's written in English. That normally isn't an issue, but when it's that specific and the tasks are kind of vague for me, yeah. Moving on. It's a good site. Use it. It is good, and it's not only for Zig. I can't remember how many languages there are. Yeah, there's a lot, right? I think I started just doing. Do they have Kotlin? I think it was Kotlin or Java because I have to relearn Java as well for work. Learning Zig. Installing language style. I think that this one, let's drop that one down there. And let's just take it from the beginning. Assignments. We have already found that we have this const, and if it's a const, we can't change it. And if we say it's a var and we don't change it, we will get an error saying that you're not using this variable. It should be a const. I like that. It's also nicely described here. Const var identifier, what's the name of the box, and what can be in the box. And then the value to put into the box. I'm not constant variables must have a value. If no known value can be given, then undefined value, which how do we pronounce this? To any type may be used as long as a type annotation is provided. Oh, so you can use undefined, but then you have to be sure to give it the type so it knows how many bytes to allocate for that value. Okay, I think I got that. And this cast as, again, they're just using it right now, but they're oh, okay, it actually says right here, ampersand as performs an explicit type. Is it me that just have never seen the word? Because normally I would just call it a casting to this type. Let's ask Google. I have used Google for reject everything. Doesn't have this, yeah.
Coercion. Coercion.
Coercion. But isn't that persuading? Coercing people? Coercing? Okay. But again, different languages have different languages and way of saying the same things. Okay, arrays. Arrays are denoted by, yes, where n is the number of elements in the array and t is the type of those elements. So how many and what type? And it's missing a single detail here. As I understand, you can say this and then follow it by a colon and a 0. Then it will be 0 terminated. Right now you just have an array of letters, but it's not 0 terminated. And okay, we can just leave it blank or underscore to infer the size of the array. Again, then it should be known by at compile time. To get the size of an array, simply access the array's length field. Got that. If expressions. Accepts bools. So again, this is something I found being different in Zig. It accepts bool. It doesn't accept just an integer value. So you can't just say if this value, because it doesn't see the value in other languages. Oh, okay, it says it right here. Unlike languages like C and JavaScript, there's no values that implicit coerce to Boolean, coerce to bool values. So you can't just use integers and expect it to be, if it's 0, it's false, and every other value is true. You have to say the value, the variable equals something. So it makes a comparison that is a Boolean. Const true, variable unsigned integer of 16 bits, 0 if a, you can do that because that's true, then increase that value, else increase it by 2, expecting it to be 1. Yes, because it's true. If statement also works as expressions. Oh, I really hate that. Yeah, it's the same in Kotlin. I don't remember it being that way in C#, that an if statement can actually return something. So yeah, if this is true, then return 1, else return 2. So here we're just adding 1 or 2 to the variable. I don't like that notation because we have this question mark colon that does, oh yes, that exact same thing. It does not exist in Zig. Yeah, and I like that notation a lot more because this says this is not an if statement as an if statement. This is something else. This is something that is expected to return something. So I like that two things being separate, but yeah, it's again, it's just a question about taste. I like this. over this. But it's good to know that this is possible and the way to do this in Zig. While loops. I feel like this way of learning is a lot better than just looking through the language reference. That was a stupid way of starting the streams. But yeah, again, learning. It's been, yeah, I don't know. It's been years and years since I learned a new language. No, it's been more learning by doing. The last thing I learned was Kotlin, and I just viewed YouTube videos and asked Reddit, Stack Overflow, and so on, and just played with the language. I actually didn't go through it step by step as I'm doing with this. I think that this might be more the more right way to do it. I know that people learn in different ways, but this would give me a good idea of what the language is actually capable of, instead of just seeing some of the things that, okay, this, I can use this, I can use in this. And then I'm just going to use that instead of maybe using what is actually the better tool for the job. It's kind of the old saying, if you only have a hammer, everything looks like a nail. And I think that's really true. So having an overall good idea of everything the language can do, you can always dive into parts you're not strong in. So, okay, moving on. While loops. 6 while loop have 3 parts: a condition, a block, and a continue expression. Unsigned bytes equals 2 while I is lower than 100, multiplied by 2. See, yeah, that's completely like in every other language I've ever touched. It looks familiar. Again, while this is true, with a continue expression, what does that mean? So what does this do? Here I think they're missing some explanations. So is it just it, whilst this is true, it does this, and then when that has been fulfilled, it moves on to this one. So if I is less or equal to 10, so this is going to end up being 10. Oh, no, 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 no. Is that for each loop? So it's going to be I is equals to 1, 2, 1, 2, 3, 5, the Fibonacci numbers. Feels like it's the Fibonacci numbers. Where did we have an output? Hello world. And yeah, I, come on. I'm used to the shortcuts from IntelliJ. Why doesn't it output anything? Doesn't it output from standard debug print in test functions? Maybe it doesn't. What about this? But then we have the problem with trying to output a number. Oh, you can't do that. Why can't I do that? Use try. Oh, come on. And do you want to bet that you can't have a test that returns an error? Yeah. Oh my God. I just want to run a test that outputs something. For F's sake. Yeah. Then we're just going to take this, go to this. Come on. You can do it. You can do it. I know. No. No. That was good. What are you? Duplicate structs. Did I make another main? I did. I think we're just gonna remove that one. Take this one. What was it? Those two. Uncomment. Let's just run this. Thank you. Oh, damn it, I'm stupid. Of course, first it adds 1 to the sum, then 2 to the sum, and 3 to the sum. Sum. There it is. Yeah. Starts out being 1. If we start at 0, then what are we gonna get? First we add 1, then we add 2, then we add 3, 4, 5, 6, 7, 8. Yeah, right. Okay, so that's okay, but this to me looks more like I don't get why you would do this, because wouldn't that just be the same as having it in there? Wouldn't that give the exact same result? 0 to 55? No. So it does it after the fact, so it would be the same as doing this. But then why add that to the language? It feels like it's obfuscating a bit more, because when is this being done? Okay, we have an option called while with continue expression. So I guess it's while this, do this, and continue, and you do this. But can this be more than just one expression? Can it be a complete set of code or something? No. Let's move on. With the continue, yeah, it just skips if it hits continue. So if I equals 2, it's just gonna continue, so it doesn't do this. And with a break, if it hits 2, it just breaks the while loop before this condition. So it's actually stop, do everything in here while this is true and this is not true. Or this is not true. For loops. For loops are used to iterate over arrays and other types, to be discussed later. Yeah, that was what I was talking about. What can we loop over? For loops follow the syntax like while. For loops can use break and continue. Here we had to assign values to underscore, as Zig does not allow us to have unused values. Yeah, but this is not unused. That's just having the compiler infer the length of this array that we call string, because it's actually a string. I don't know if you do this and it knows that the length of it, if it, no. When we're talking about strings, we don't have, we need the zero termination, a null termination, as we have in C, I guess. It's just a help when you write out the string. If you just have memory allocated with this information, you need a terminator to indicate that the string is done, because you can allocate a lot more memory than a certain string is, and just to stop it somewhere, you indicate it by the zero value or null value. For string, then again, we have this double index that we are looking through this, and we have an index that starts at 0 and increases. One is called character, the other one is an index. This, I guess, is this usize weirdness. And here we're just assigning it to something or to nothing, just to have it work, to show how the code is structured. For string with one iterator, yeah, we have again in chat something that is just spam. Can't we just remove that one text? As I'm completely new to this. Pin this message, click to reply. No, I just want to remove it. Why can't I just remove? Ban him, unblock, account suspended or deactivated. Yes, but I just want to remove it. Is it visible in the stream? Yes, it is. So I would like to just remove it. There's no need to have it there. Click to reply. No, I just want. Come on, Twitch. Give me a tool so I can remove the message from the chat. I don't want to clear the chat if just this one guy doing stuff he shouldn't. Weird. Okay. There's some things with Twitch I need to learn, because that was annoying. If people write something they shouldn't, then allow me to just delete that one message. I can pin it and I can reply, but apparently I could also ban him, timeout, and warn him, and I can unblock and report him. But I can't just simply remove that message he wrote, which is weird. But okay, back to the code. Where are we at? Oh, sorry. For string, loop through the characters. Yes. String, again, that one, an index. And if we use this, we don't have to use the characters, but we have an index. I've been using this a few times where I don't actually need the information from the array, but I need to have an index into the array. So this allows me to index into something else, or the array itself. I could do something like string index to get the different values. Or if I wanted to do some manipulations or access it in different order or something, it's a good thing to know that you can do this. For string, do nothing and do nothing. And that is valid. Yeah, why not? Functions. All function arguments are immutable. If a copy is desired, the user must explicitly make one. Unlike variables, which are snake case. Oh, we are using snake case. Functions are camel case. Here's an example of declaring and calling a simple function. A function called add5, coming from C#. I like the functions to start with the capital letter. But yeah, I can get used to that. I think we are doing the same in Kotlin. It takes a variable x and it returns unsigned integer, and it just adds 5 to that value. Function, make a const of 0, and it tries to do and add 5 to that 0, so it should expect a 5. We will expect that the return value is a unsigned integer of 32 bits, and the value would be 5. Recursion is allowed. There we have the Fibonacci. That's a typical thing to show. Unsigned 16 bits only. If n is 0 or n is equal to 1, return n. So it just returns the number 0 or 1. If not, if it's a different number, we call the Fibonacci, the function itself, with the number we gave it, -1, plus the Fibonacci number of n minus 2. So we are actually adding together the previous two numbers, but those two numbers are based on the previous two numbers and so on until they get down to 0 or 1. And we're going to test it with Fibonacci starting by 10. So it ends it with 10, and it will return 9 plus 8. The Fibonacci, the 8th and 9th Fibonacci number, and we'll just recursively call it. So nothing new there. Values can be ignored using instead of variables and const declarations. Yes, we know. Defer. I'm really looking forward to seeing what that is, because it's something I haven't seen before. It's used to execute a statement upon exiting the current block. So it's a delayed execution of something. Defer x plus 2, so it should be 7. But this isn't executed until we exit. Oh, we exit the current block. These are called blocks in Zig, apparently. Normally I use the name scope for this, but current block, I don't care, block or scope. So as soon as it hits this one, it will execute that one. And if you have multiples, they are executed in sequence, I guess. Multiple to first and single block, they are executed in reverse order. Ooh. Ooh. But why? Oh, it's probably because every time you add a defer, you add it to a stack or push it to a stack, and then you just pop it off when you execute it. Where would I use that? Where would I use that? Defer is useful to ensure the resources are cleaned up when they're no longer needed. Instead of needing to remember to manually free up the resources, you can add a defer statement right next to the statement of, oh, that is a brilliant idea. And that also why it might have been designed to be executed in reverse order, because when you allocate something, and you allocate something more and more and more, you clean it up the other way around. So you don't clean up something top level that is actually accessing something at a deeper level. So that is kind of brilliant. I will have to remember that one. Errors. Oh my god. An error set is like an enum. Details on Zig enums later, where each error in the set is a value. There's no exceptions in Zig. Errors are values. Let's create an error set. So this is the magic word, I guess. And we just call it access denied out of memory and file not found. And set cores to their superset. So we have allocating errors, and we initialize an error of type out of memory. Test allocate error out of memory. That's a lot of assigning just to have an error. Coerce error from a subset to a superset. Okay, let's take it one line at a time. Allocation error. That's this one. Dot out of memory. So it takes this one out of memory. It's part of this one. Try expect error to be file open error out of memory. So we are doing two different, but because it's called the exact same thing, we can coerce or cast it to a superset of it. Yeah, because this is a subset of this one. We are using this one, error out of memory. So we can compare it to this one. Okay. An error set type or other types can be combined with the bang period exclamation point. Oh, God, exclamation point operator to form an error union type. Values of these types may be an error value or a value of the other type. Sorry. Let's create a value of an error union here, where catch is used, which is followed by an expression which is evaluated when the value preceding it is an error. The catch here is used to provide a fallback value, but could instead be a no return, the type of return while true, and others. Yeah, didn't make much sense. Let's look at the code. Code makes sense. Explanation doesn't. Like, yeah. Error union. And maybe error. Allocate error. Action error. Or no error. Maybe error. Catch 0. Okay. What's going on here? We're making a cons called maybe error of type allocation error or unsigned 16, and we set it to 10. So that will return 10. No error equals maybe error. What's maybe error? What is this? It's not referenced anywhere. Oh, one, it's referenced right there. Why wouldn't it just highlight it when I search for it? I'm an old blind guy. So this just says I want this to be equal to this one. And if this is an error, then assign it to 0 or what? Yeah, this one, as this is set to 10, then it should be 10 and the type should be unsigned int. But isn't that already true for the maybe error? Oh, okay. Here catch is used, which is followed by an expression. Yes. Which is evaluated when the value preceding it is an error. So if this is an error, we catch it and return 0. Okay. It's a completely different way of doing error handling. Let's see. If we did this and we returned something that wasn't a U16, I guess that this would fail and it would have an allocation error. Or if we called something that tried to allocate a piece of memory and we got an error, this would be an error. This would say this is an error, then catch it and return 0, and this would return 0. So it's kind of a weird way of doing it, but I think it explains what's going on quite well. Function often returns unions. Here's one using a catch where error syntax receives the value of the error. This is called payload capturing and is used similar in many places. We'll talk about it in more detail later in the chapter. Side note, some languages use a similar syntax for lambdas. This is not true for Zig. We have a function that can return an error. And again, we have this oops. So we have the same definitions like here. We're just making it inline, I guess. And it can return void or the error. And returns error, oops. So this is just a function that always returns an error. So this could be omitted, but it's again to show that it can either return void or the error. Failing function, it's called this one and catches the error. If this doesn't fail, this catch won't be called, right? Just gonna test that one because that's nice little one. Yes, returned an error as it should. Returning an error, all passed. But if failing catch, can we? No, we can't because we don't know what it is. It's a void. Either it returns something or it doesn't. So we need to catch it that way. I'm not sure I get it fully. There's something lagging here. Failing function catch. So this is only handling. Yeah, okay. It is a void function. So we don't have anything else to work with. But if we had 232, we could say, right? Okay, we can't. Unused local const. Oh, come on. That is kind of annoying, but I get why we still pass. Can we print? Nope. We couldn't print anything, right? Strangely enough. Yeah, it did output. Why couldn't we output before then? Let's see. Yeah. See, it just returns in there. If we remove this one and try to run it, because it will fail and it will try to do this and the catch doesn't work. We're gonna do this and then we're gonna change this and just say no, not, come on, there, value of 34. So it makes sense. So now we can return both. We can return a value or we can return the error oops. And if it returns the oops, it handles it here. Try accept this one. Oh, try expect. So this is just for the test. So the right way to do this would be if it ever reaches here. Yeah, the U32 return should be equal to 34. I know it's a weird, stupid test, but yeah, it works. Cool. Try X is a shortcut for X catch error return error. Okay, and it's commonly used when handling errors isn't handling an error isn't appropriate. Say try and catch are unrelated to try catch in other languages. Yeah, it smells a lot like try catch. A function can return an error or an integer, and it tries to do this fail function. It tries to call this one, and if it fails, it just returns right away, as I understand. Else it returns this. When we try, this one equals this one catch error. Okay, so what is the... Okay, so this is actually doing what we just did. We're just adding try to this call. Fair enough. So we catch the error. We have access to the error right now because this failed. So we're going to catch it. We try expect that the error equals this one and returns exactly like we did up here. Well, function catch error. We just added the try in front of this. And we can try, it's never reached. Yeah. Error deferred block, like defer but only executes when the function is returned from with an error inside of the error deferred block. Damn, error is a long chapter. Error defer looks like the verb. Problem, fail counter, it returns error, oops, or void. Error deferred problems. So this is error deferred. Okay, so this is again called when this is reached the end of the function, because that's the current scope or block, and it will increase this one. So try failing function. I guess that failing function is still this one, so it's just gonna fail. So this is gonna fail, it's gonna catch it, increase problems by 1, and return. Oh, and we have this one set to 99. So we're gonna call it, catch the error, try expect, we get the right error, which is still the error oops, and try expect problems to be 99. Yeah, but if we test it for problems at before this line or after this line, it will still be 98. But why you would use error deferred and not just defer, I don't understand why you would have both, but only executing when the function is returned from with an error inside of the deferred. Okay, only if. So again, if this doesn't return a problem or an error, so if this didn't fail, this wouldn't be executed. Nice. I like that. I kind of like that. So we have the ability to call cleanup code at the end of a block, and if there's an error, we can execute some different. Are they exclusive, or will they both be called? Error union returns from a function can have their error set inferred by not having an explicit error. Yeah, sorry, mumbling here. All possible errors that the function may return. We create a file, it can return void, an error, or void, error, access denied, context error, error, access denied, void, equals create file. Okay, so we can actually make a variable that contains this. What is the type of that? What would the type of this one be? Sorry. What would this one? I think it's pretty weird. I set that to do not disturb, but still it accessed the call. Yeah. Create file. Yeah, I just got completely out of the groove here. So let's just run this test, see it passed. But what I want to know is the type of this X. Sorry. I know that we tested the type somewhere. Find type. No. Okay. I think it was ampersand type. Yeah. So if we do this, sorry about that. Somebody doesn't understand that when you do not pick up the phone, you do not pick up the phone. I wanted to know the type of this one, and I had the print here. Can we combine this? Can I get the type of this? Can I do this? And it's from the X. I think that it shouldn't be this, that's for sure. Have this one, language reference. Type of bytes. That should be just like this. Value. It's an error. It actually is that type. Nice. I like that. Where were we? Errors. Oh my god. Yeah. Where were we? Yeah. Well, I'll end the stream for today. And of course, this will be reposted on YouTube, and you can add comments and again have fun on my expense. If you find me lagging in knowledge, or you have something you want to contribute with, just let me know. And if you have some nice explanation of some of the things we went over today, then please share, because I am learning and I want to learn. Thank you, and have a nice day.